All right. Good afternoon, good morning, whichever it may be for you. I'm Blaze Stewart. I'm a senior consultant at Wintellect, and today we're going to be doing a webinar on the survey of containers on Azure. So this will be a fast-paced webinar because we do have a lot of ground to cover. But before we begin, I just wanted to point out a little bit about Wintellect. If you're not familiar with who we are, we're a consulting company, and we do ILT or instructor-led training, and we also do on-demand training with one like now. And we, in the space of the container space, we are a Docker partner, so we do partner with the company Docker, and we do provide consulting services on Docker as well as courses as well. So we also have a gold partnership in DevOps, which also relates to a lot of what we're going to be talking about today. And we have a fair number of books out there that you might be familiar with from Jeff Procyse, John Robbins, Ken Scriber, Justin Smith, and Jeffrey Richter. So fairly well-known industry influencers that started Wintellect, and they started off as instructor-led training, and have started the consulting business. And so now Wintellect is a industry leader in both consulting and instructor-led training, providing some of the world's best content in these areas. And some highlights, we do have multiple competencies, integration on Azure, and that's one thing that we're going to be talking about today, Docker partnership, as I mentioned, and we have multiple MVPs, our CEOs in RD for Atlanta, Microsoft RD. So we have a lot of vested interest in the Microsoft space as well as tight partnerships with Microsoft on a lot of different things as well. So that's a little bit about Wintellect. I want to transition and let's look at today's agenda. Our agenda for today is going to cover a lot of topics. We're going to look at the offering from Azure and what they can do on containers. And there's a lot of different ways to run containers on Azure, so we're going to have to move through these pretty quickly if we're going to get all this in and save some time for questions. I would ask that you save questions to the end. There's a place to put those in on the webinar. There, if you go onto the control panel, you should see a block for questions. If you want to type your question in there, I'll get to those at the end of the presentation. But let's dive in and let's start talking about containers on Azure. Just a brief introduction to containers. If you're not familiar with what a container is, I hope that you are, because it could take another webinar just to explain what this is. But essentially, what a container is what virtual machines did for hardware, containers do for an operating system. So instead of a virtual hardware like a virtual network card, virtual hard drive, virtual CPU, and so on, that is exposed to an operating system which you use to create a virtual machine, a container is essentially exposing a virtual kernel, which then exposes that virtual kernels to an app. And so it essentially eliminates the need for a guest operating system for every app that you might be running on top of a hypervisor or a guest operating system. So you have a host operating system, guest operating systems, and then libraries and apps on virtual machines. But for containers, you just have the host operating system, a container engine, then your apps run on top of a abstraction of the kernel. So it has to share the kernel with all the other apps running on that same platform. So it does eliminate some of the overhead for running apps in a given environment. But there's trade-offs for that. With no further ado on containers, though, let's talk about what the containers can be, what you can do with containers. Whenever you build a container is essentially just a virtualization technology, but they all start with an image. And Azure has the ability to store container images on top of what they call Azure Container Registry. Azure Container Registry, or ACR, is a place where you can use for private images that you want to store in Azure in a secure way. So you have like a proprietary code, or you don't want to put it out there in a public registry such as a Docker Hub or something like that, you can spin up Azure Container Registry. And this is a really easy to do way to get a private registry. And then once you have your registry created, you can go about pushing images from your local machine to to that registry that can be used in many of the offerings that we're going to be talking about today. And if you want to look at the offering from Microsoft, check out that website, or you can go to the Azure portal, and we'll look at it in just a minute in a demo. But you can see just how easy it is to set this up and actually use it. So I wanted to start off with Azure Container Registry because we're going to be using it in a couple demos. But it's not actually a way to run containers. The first way that we're going to be able to talk about when we run containers is Azure Container Instances. An Azure Container Instance is essentially a small standalone instance of a container. It's very easy to use, a simple way to spin up a container on Azure it's just a single container. It doesn't have any knobs and switches that you can use for a variety of different tasks, but it does give you the ability to spin up these containers and spin them up quickly. And because it's not designed for large scale deployments, it gives you the ability to build out short-lived containers, transient workloads such as builds or proof of concept type work and stuff like that. So the scale of this would be small, but it is a good way and easy way to just test containers out or to kick the tires on a piece of software if you don't want to spin up an entire container environment. So very small, very easy to use. I wanted to talk about this one in particular because I use it a lot for POC work that I've been doing, and also it does have the ability to use it in DevOps chains. So if you need, like I said, a build server, you can easily use container instances as a way to do that. So let's flip over and do a demo in Azure Container Registry and Azure Container Instances. I'm going to show you how these two can work together to produce a actual app. So let me exit out of PowerPoint for a second. Now on my desktop here, I have a folder, and in this I have a couple files. I'm going to build a container that's basically on using this index.html and a Docker file that builds, it copies that into a Nginx uh, image, and then deploy that image to a Docker container instances. So it's very straightforward, not a real fancy demo, but it does demonstrate what we're talking about. So this is the website, what it would look like. This is served up from a local host. I mean, actually, I'm serving it off my file system here. So I'm going to deploy this website or this web page to Azure using Azure Container Instances. So what I've already done here is on Azure, I'm going to go out to the portal, and I'm going to log into my MSDN account, and I'm going to pull up the portal here, and I'm going to create a new instance of Azure Container Instances. So on Azure, if you hit the new, and they got an entire group for containers, and you'll see a lot of the offerings right here. So I'm going to select Azure Container Instances in just a moment, but I wanted to flip over and show you Azure Container Registry, which is right here. Azure Container Registry, I've already deployed that image for that website to an image on my Azure Container Registry. So I have here ACR running here, and this is my simple container registry. And in this, I have one repo, which is just a repository for the image that I pushed that contains this website right here using Nginx. So I'm going to use this container registry to actually pull from whenever I deploy Azure Container an Azure Container instance. So let's go over here to Resource Group, to New, and go to Containers, and then go to Azure Container Instances. And I'm going to give it a name. I'll call it Blaze Demo or something like that. I'm going to make it a public image. I'm going to use a private image, and I'm going to use, I have the settings for this already right here. This is my username and password since this is a demo. Container image is going to be this / and then I'm going to go Azure -demo, and then my logon is going to be the name of my Azure Container Instance, and this is my password. It's just the key, and this is the username for this. So I'm going to put that into Azure Container Instance here, and then I'm going to create a new resource group on Azure, call it Blaze Demo, and then I'm going to, and that's filled out this form to deploy this particular image to Azure Container Instances. And then I'm going to come over here and I'm going to say I'm going to use 1 gig of RAM, And I just want one core. That's all I need for this. It's a fairly small container. It doesn't really need that much in terms of resources. Notice I can use Windows containers or Linux containers here. And I'm going to click OK, and it's going to validate, and then click Go. It'll take a few seconds for this to deploy, so let's wait for that to deploy. And once that's done, we should be able to launch the Azure container Azure container instance using the IP that it assigns to it. So, um, but actually have already created this using ACI demo here, and this is actually already deployed. So I'm going to actually use this one instead. So this is my demo here. Send that out, get that out of the way. Oh man, it deployed it really fast that time. It took a while earlier, so I was going to flip over. So that's good. It's good to know. So let's go over here and just use the one I just deployed, and it's going to give me an IP address that I'm going to copy and paste in my browser, and use that to load up my website. And let's get this IP address. There it is. And then Control T, paste that in. And if all goes well, we should have a website on this container instance right here. All right, still pulling that up. I have another one running over here, so maybe I could pull this one up. This one's already running, so. Oh, there it goes. I did pull it up. It just took a minute to start the container. So there's my website running on that public IP that Azure assigned to it. So with that in mind, let's go back to our slide deck and let's talk about another offering from Azure, which is app services for Linux. Now, if you're familiar with app services, it's traditionally been specific to Windows type workloads that you would install on something like Internet Information Server, IIS. And then Microsoft has recently added to app services is for Linux, and this is built around containers. So um, they took the entire paradigm of this is they have actually several pre-built containers that you can install your app into. So for instance, if you have a Node or Python or PHP app and you want to run that on a Linux host, you can use app services for Linux. And really what it's doing under the hood is taking that app, containerizing it for you, and then deploying it onto Azure app services for Linux. Now you can also bring your own containers to this as well. So if you want to deploy a custom container that you've built, like what I've shown you already, then you can use that as well on app services for Linux or one of these pre-built containers they have for you. So it gives you a lot of flexibility in what you can do with this. There's also a lot more you can do with this than what I'm actually going to show, but this is a very easy way to get a website or web service up and running without having to spin up any kind of infrastructure to do it or spin up a cluster. And it also gives you the ability to scale or integrate with using and CI/CD pipelines and so on. There's a lot more to this one than what you can do with Azure Container Instances. So let's demo this one with App Services. Now, App Services is very similar to Azure Container Instances. The biggest difference is, like I said, it's got a little bit more scale to it, a few more knobs and switches. So if I come back over here, I have already built a demo around. Let's see, did I delete that? ACR, Azure Container Services. Is that the one I just did? No, it's not that. Let's go ahead and deploy another one then. Let's go over here to containers. This doesn't take very long. And come down here to containers and then select web app for containers or app services for containers. And I'm going to call it Blaze Azure or something like that. And it's going to create a new resource group, create an app service plan, and I'm going to configure my container here. Now notice I can use Azure Container Registry here, and I can select from that the image I want to use and use the latest, and I don't have to specify a startup file. So this is actually using a pre-built container that I've already built, and it's going to deploy this one to Azure using Azure App Services. So I'm actually going to deploy the exact same website or the exact same container to App Services using this. So with that in mind, let's let that deploy. And close this one out, and that'll take a few minutes to do. Um, Azure shit all late today. It's going really fast. So let's go over here and see if we can pull this up now and get the public IP address for this particular one. So if I click on this, this should launch my website on using that URL that I assigned. So Blaze Azure, AzureWebsites.net. Let's give that a second to pull up. It's got to pull and start the container. So, and there's my website running on Azure App Services for Linux, or Web App for Linux, as it calls it. So that's two that we've seen already, and these are actually all real easy to configure. This one, notice it gives me a lot more options than Azure Container Instances did. I have the ability to do CI/CD with continuous delivery. I can also integrate it with webhooks. So if I push something to, say, a registry, it will automatically update the container inside of this with webhooks and things like that. So there's a lot of things, and you can scale up and scale out using app service plans, and then do a lot more scalability built into this that you wouldn't otherwise get in Azure Container Instances. So it's a little bit more robust of a platform. It'd be more ideal for websites or web services that are long running, that you actually want to deploy as web services, or a website that you want to containerize and so on. And it's actually running on Linux under the hood. So let's go back to our slide deck, and let's transition. Let's talk about a few offerings that I don't have demos for, but I do want to talk about um, these, talk through these, because they are ways of running containers on Azure. And these are a little bit different type workloads that you might see. So the first one I'm going to talk about is Azure Batch with Batch Shipyard. Now this is really two different things here. Azure Batch is used for batch jobs on Azure. So it's not really designed for running websites and web services. It's going to be more for running um, it's going to be more for running long-running jobs that you wanted to, say you wanted to render a video, or you wanted to, or you have a build that takes several hours to complete, or you want to do some big data processing, or you want to do something that requires compute intense operations, and you want to be able to do that with a container. And the scenario behind this is something like big compute, or just heavy compute jobs that you can schedule, walk away from it, and come back in a period of time, and it will output the results to some kind of file system or some kind of dump of some kind that you're expecting. And the reason why you would want to use this with containers is because with containers you can pre-install all the dependencies and all of the software that you need to do the batch job with. And then with Batch Shipyard, this is a set of utilities where you can take that container and put it into a batch compute pool on Azure Batch, and then schedule that job to run at some point in the future, or you can invoke it manually, and then it will actually launch as many containers as you specify. So if you have a large batch and you want to use some kind of maybe 10 or 15 different nodes to actually do computations, Azure Batch and Azure Batch Shipyard give you the tools that you need to run batch jobs as containers on Azure. So I don't have a demo for this because it is not simple to, it's not a trivial thing to set up, but I would encourage you to check out those links there if you're interested in using Azure Batch and Batch Shipyard for batch jobs. The next one I want to talk about, again, I don't have a demo for this one either, is Service Fabric. Service Fabric is a orchestration platform really for Azure, and it can be run on-prem as well, and if you set up on-prem clusters for Service Fabric. But the idea behind Service Fabric is that you can orchestrate microservices and containers using Service Fabric as the orchestration technology. Now we're going to talk about other orchestrators later on, but this one is specific to Microsoft. So this is the Microsoft offering as a orchestration technology. And what it does is it gives you the ability to deploy microservice apps, which are a special kind of applications that run in Service Fabric, or the ability to deploy containers into Service Fabric as well. And so what Service Fabric does is it does all the kinds of things that you would expect an orchestration engine to do. So it gives you the ability to scale out massively across multiple nodes. It provides you the networking, the monitoring, and the automatic scaling, scale up, scale down kind of things that you would expect from an orchestration technology, and all that's baked into Service Fabric. So really, with Service Fabric, really what you're trying to do is build. You focus in on building the containers and the microservices, and then you let Service Fabric kind of handle the rest once you deploy the app to it. Um, what you would expect from a orchestration. Now, this is designed for medium to large container load. So the first two things that we looked at, Azure Container Instances and Azure Container web apps for containers or web apps for Linux, are designed for smaller loads. These are designed for medium loads to large loads. So it's going to deploy clusters and do all that kind of stuff on Azure for you. So think about this one if you really want to build out like a true you want to build out a true DevOps pipeline that is massively scalable, and so on. So let's go on to the next one, which is Azure Container Services. Now, this one is the flagship offering from Azure. Azure Container Services is probably the one that gets the most attention on Azure. So we've seen Service Fabric, we've seen that Shipyard, we've seen uh, we've seen web apps for Linux, and we've seen container instances, which all can run containers. But the one that is probably the flagship product that is designed for general consumption for probably most use cases is going to be Azure Container Service. And now Azure Container Service is essentially a script that, and plus some tools that will spin up one of three orchestration engines for you on top of Azure IaaS or IaaS. So you can go out to Azure to the Azure Marketplace and then select Azure Container Service, and then you can pick one of three orchestrators, be it Swarm, DCOS, or Kubernetes. Now, each one of these does orchestration in a little bit of a different way. So be that Swarm, which is going to be more native to Docker, the Docker ecosystem, DCOS, which is data center operating system, which containers is just a small part of what that really can do, and then Kubernetes, which was came out of the Google camp. It's got some different assumptions on how it does containers as well. So depending on which one you're using, depends on how it's going to work. Now for apps, if you're specifically focused on apps, Kubernetes is a really good choice if you're going to be using web-focused applications. However, Swarm and DCOS have their place as well. Swarm is really good for if you want more granular control over the environment, and DCOS is if you want to integrate this with the ability to scale out not just containers, but VMs and other types of databases and so many other things that DCOS can orchestrate as well. So each one of these offerings has a different use case, but there is a lot of overlap between them as well. And this is like Service Fabric designed for medium to large workloads. So essentially what this is going to spin up is a cluster, and that cluster is going to have master nodes and worker nodes that are agent nodes that it's going to deploy container workloads to. And these are not as easy to set up as something like web apps or Azure Container Instances, because they do have a lot of more moving parts to them, but they are really worth using if you're planning on deploying, like I said, large scale workloads and you want all the stuff that orchestration engines offer. So I do want to do a demo with Azure Container Services using Kubernetes, and Kubernetes being kind of the more popular of the three, it's one that's getting a lot of attention these days. Kubernetes, as of yesterday, was announced that Azure, I'm sorry, not Docker, was going to integrate Kubernetes native into the Docker platform rather than just being a third-party bolt-on to Docker. So now as Docker is essentially offering both Kubernetes and Docker Swarm as orchestration options inside of the Docker ecosystem, rather than having to use a third-party tool like Kubernetes and bolting it on top of Docker. So let's flip over to Azure, and I'm going to show you this using a demo again. Now, to do this, what you have to do is you have to spin up Azure Container Services on Azure. And that's real easy to do, but it does take a while for this to deploy. So I'm going to use one that I've already built. If you go over here to Azure Container Services and you select this, with Azure Container Services, if you can say, I'm going to say Kube Demo. I'm not actually going to deploy this, but I'm going to show you the deployment process. And once you're here, you can select these orchestrators, DCOS, Swarm, or Kubernetes. And this one you have to put in SSH keys and a service principal. I don't have those settings, but if you want to deploy Swarm, for instance, it's only going to ask you for a username and SSH key. But you can deploy any one of these to using the template, or you can deploy them from the command line for that matter. So once you have this up and running, um, you can come back over and it'll deploy and you can go back over to the resource and it's going to look like um, just a resource group. So I have demo ACS here and I've got a Kubernetes cluster deployed on this. Now, notice this is deploying several virtual machines on here, as well as all the infrastructure to put those virtual machines on and onto Azure and connect those up to a network and so on. And what I'm mostly going to be interested here is in the actual blade that displays this master FQDN, which is the fully qualified domain name for the master node, because this is where I'm going to interact with. The master node is who I'm going to interact with whenever I actually go to deploy this container. Now, this is a small instance. I only have one node because I'm only doing a demo on this, but a real Kubernetes cluster, you would want to have multiple nodes in a scale set for your cluster manager nodes, and then you would have an agent pool where you want more than one agent running as part of this cluster. So you'd probably want to add three or more. Typically, is the kind of the magic number for a cluster that's got high availability and fault tolerance and so on built into that. But just for demonstrations, I've only deployed a single agent node to a single master node, just so I can deploy one container to it. Kubernetes does have a lot of overhead, so make sure you have a beefy enough VM to run it on. And in fact, it won't let you deploy some of the smaller VMs on Azure just simply because it won't run it because of the resource constraints. So I'm already connected to my agent. My master node here on Azure. So what I did is I SSH'd into that using the SSH key that I provided to it whenever I created that. So this is PuTTY connected to this fully qualified main name here, and I've remoted into that. So Kubernetes has a web UI. However, you most of the time, if you're going to interact with Kubernetes, you're going to be using the command line just simply because it does gives you a whole lot of options and a lot more control over the environment if you use the command line. So my demo isn't going to be using the web UI, although you could do it in the web UI. So for this, I'm actually going to pull it from Docker Hub. I'm going to pull that same Azure demo. And what this is going to do is it's going to run a service called Azure Demo from this image here. I'm going to create two replicas of it on port 80. So to do that, I'm going to call kube control, and it's going to spin up this running on Kubernetes. Now I can't access this just yet without first creating a load balancer in front of it. Now, so to do that, I'm going to expose it using the kube control um, expose command, and I'm going to tell it to use this deployment that I just created. And so I'm going to map port 80 to whatever, and I'm going to use a load balancer configuration for those two replicas that I have running on there. So, okay, looks like it's already running. And let's see if we got here. And let's call this and see what it, and this is what I'm going to call this command get service Azure demo to get the public IP for this. And notice it's got external IP already, and it's got an internal IP. Now I should be able to use this external IP right here to connect to it in my browser. So that's one running on app services. So if I come over here, I just pulled it up on Kubernetes. So this is actually a website running on Kubernetes using the Kubernetes cluster. So this is the same website. I just used it on a Kubernetes cluster. So we've seen this website deployed in three different environments. We've seen it on Azure Container Instances, Azure Container, app services for Linux in a container, and then we've also seen it now on Kubernetes. Now, Kubernetes is a very powerful tool for doing all kinds of things with it. I mean, it does scale out. I could scale out this out to literally hundreds of nodes, thousands of nodes, depending on the resources that I have. Now, and you're not going to be able to do that with other the smaller offerings. You could do it with Service Fabric, Swarm, or DCOS, but you're not going to be able to do that with container instances, or you're not going to be able to do that with app services for Linux. So this is a very straightforward demo for Kubernetes. Now I'm going to take that deployment and I'm going to delete that and come back over here to my SSH tunnel and I'm going to delete that instance and should, there it goes, it's been deleted. Now let's close out these demos here. Now I do want to go back to my slide deck. I really want to talk about Docker for a minute. Now, Docker is the engine behind all of these. These are all running Docker containers. They are all running containers that are really running on the Docker container engine or Docker, or what they call Container D, which is open source. So a lot of projects integrate that with their product offering, and Microsoft has too. Docker itself, everything we've looked up to this point has been an offering from Microsoft on Azure. I mean, they're using some third-party offerings like Kubernetes DCOS or Swarm in container services, but the offering itself is created and managed by uh, Microsoft. This offering on Azure is actually from Docker, and this one is intended for folks that are more wanting to get that support from Docker, not so much from doing it yourself or getting the PAS or the PaaS offerings from Microsoft. So if you have Docker EE on and you want to use Docker EE, then this would be the way to go on Azure. So what Docker has done is they've built out the templates and all of the infrastructure using ARM Resource Manager or Azure Resource Manager, and they give you the ability to create clusters that are scalable on Azure using the tools available that Docker has created for Azure. And with this, you can take your commercial support for Docker EE and plug that into the Docker for Azure and use it as a offering for deploying containers on Swarm or Kubernetes, and also be supported from Docker if you have trouble. So it's a good option for commercially supported cloud offering on Azure, and it also works on. They also have an offering for AWS and Google Compute as well, but this one is the one I wanted to mention on Docker on Azure. Um, a few honorable mentions. I wanted to mention these as well, not because I'm going to have any kind of in-depth knowledge. I do know that these are available in the actual Azure Marketplace, and these all have kind of the same, essentially the same architecture. Red Hat OpenShift, Rancher OS, CoreOS, and Ubuntu with containers. These are all marketplace offerings where you can go out and you can either, some of these are free like Ubuntu is. Other ones, if you have licensing for like say OpenShift from Red Hat, it's supported on Azure as well. You can go out there, deploy these to Azure using your licensing that you already have, and then use these container options as a way to run containers on Azure as well. So these are, um, I don't really have a lot of information about these. I just know that they're available, and I know Red Hat is OpenShift is a fairly popular platform. CoreOS, RancherOS are two other ones to some degree or another. And in fact, Microsoft deploys basically everything they do on Ubuntu under the hood, so they are using that. Um, so let's and that's so now that we've gone through all of these offerings on Azure, I wanted to open up the floor for questions. Now, I hope that you have several questions because we did go through quite a bit there pretty quickly, which is good. I want to be able to answer your questions and maybe get some feedback from you guys as to how things are going. So let me go down here to the questions. Uh, let's does anybody see if anybody's posed any questions? Um, this isn't the most intuitive platform in the world. Okay, let's see, here's one. For scenarios where customers fill out some form at a website, should they trigger should trigger a made a video rendering about 30 minutes? Would you recommend Azure Batch? Can we run Azure Batch on command? Yes. This question is about Azure Batch, and it says if it takes 30 minutes to render a video, can you use Azure Batch for that? And the answer to that is yes, you can run Azure Batch on um, to render videos. And yeah, you can come back and you can launch it on demand. You don't have to schedule it. So, and then container, if you want to use containers for that, you can actually use some tools like, say, Ubuntu's got some. I actually wrote a hands-on lab where you did audio file conversion from one format to another, and you can install the software to do the rendering if you have that on Ubuntu or other ones, and put that in a container. And then what you would want to do is connect Azure, like Azure Blob Storage, to that, upload your source material to that, and then launch the container, and then it would write the results back to Azure Blob Storage once you're done. So it's a fairly straightforward way of doing things whenever you're running Azure Container Batch services for that. Um, let's see. Second question is, are there performance metrics on container services? Now, by performance metrics, I think you're talking about monitoring. Now, for that, yes, there are performance metrics. It's going to depend on the orchestration platform. Uh, that you can go out there and look at. So every one of those is going to handle it in their own way. Swarm does that, Kubernetes does it, DCOS does it. And you can go out there, depending on how they use that, is going to depend on how well that you can actually get those metrics um, and look at those depending on how it does. So it's hard to answer that question specifically, but yes, there are metrics out there for all the offerings on Azure Container Services. Next question is, does Azure Container Services offer monitoring and logging? Azure Container Services, like I said for the previous question, does offer monitoring and logging. It's a function of the orchestrator, though. It's not something that's baked into um, Azure Container Services per se, but Kubernetes is going to have their logging and monitoring. DCOS and Swarm each have their own monitoring and logging. And the other thing you can do with Azure Container Services, because it is built on Azure IaaS, you can bolt up the actual Azure monitoring services for the VMs that are actually deployed, so you can actually monitor the VMs using some of the monitoring and logging tools that are available for the virtual machines on Azure as well. So you have multiple options there for monitoring and logging for Azure Container Services at the orchestrator level and at the VM level. For Docker, next question is, for Docker for Windows containers, what type of isolation is used? That's a good question. I don't know. I know if you deploy it yourself, you can choose Hyper-V isolation, or you can choose just the regular, uh, standard isolation. I don't know what its Docker Windows containers. Now that depends on if you're deploying it as on Kubernetes or as a Azure Container Instance. I don't really know which isolation it's using under the hood, so I couldn't answer that question. My suspicion is it's probably not using a it's like for Windows containers, it's probably not using the Hyper-V isolation, simply because that is pretty heavy. It's probably using something a lot the lighter version of that. So, but again, that's just an educated guess. I don't really know the answer to that. But if you have the ability to deploy it yourself, such as a Service Fabric, or if you create your own instance of Windows Server running on um, Azure, you can specify that yourself. For Docker Windows containers, what kind of isolation is used? That's what we just answered. Um, let's see. What should be the best? What should be the best performance expectation uh, between bare metal, hypervisor, and a container? What should be the best performance expectation? Now, I mean, obviously, you're going to get better uh, best performance on bare metal. I mean, because anytime you put a hypervisor or container, you are using some kind of layer of abstraction. Um, so performance wise, just in terms of just throughput, in terms of raw CPU compute and so on, bare metal is always going to be better. However, let me be clear that it's not so much better that it's not worth the cost that you pay for using a hypervisor for a VM or container. In fact, they've done a lot of analysis on the hypervisor VM versus a container and the difference in performance between these two, and it's less than 1% cost between a VM and a container. So you're not really going to lose a lot by using a container, and you're not going to lose a lot between bare metal and a hypervisor. So say if you were using a VM as your container environment, which is what the case on Azure, you might have a 5% difference between bare metal and the container version of your app. So as far as performance goes, it's really not an issue in most cases, depending on how well the abstraction is done. And in most cases, it's not even because the hypervisor is taking advantage of built-in hardware assisted virtualization on the actual bare metal, and so it's really just doing some translation and putting everything on the bare metal anyway. So virtual machines run almost as well as bare metal, and the containers almost run as well as a virtual machine, so with very little loss. Let's go on to the next question here. Would you recommend using Azure Batch even if most work is scheduled on demand rather than immediately? Would I use Azure Batch? Um, uh, would you recommend using it for work that was scheduled on demand rather than on demand? Well, if you're using Azure Batch, it's going to be depending on what you're using it for. I mean, scheduled workloads are just for, I have a once a week I'm going to run payroll or something like that. You can schedule it. Now, if you need it just on demand, you can do that as well. So yeah, sure, use it for whatever. Just use it for long running batches. That's primarily what it's used for in that respect. So, and that Shipyard gives you the ability to run it on demand, or you can schedule the jobs if you like. Um, Next question, monitoring resource performance under various loads. That was, I guess, a clarification to the previous question that we had. And yes, under various loads, yes, you have that ability. Particularly Kubernetes does a good job of that, and because the way it's set up, you can set up elastic scaling up and down as you need to. And yes, those metrics are available under various loads as well. So you can definitely check that out if you want to look at that. Can Azure be used with Kubernetes to create multi-cloud clusters? Um, that's a tricky question. The answer to that is yes. However, I don't know that I would use the container off. What Azure Container Services does, if you're going to use Azure Container Services, I don't think I would use Azure Container Services to create a multi-cloud cluster. And the reason why is because Kubernetes Azure Container Services integrates with Azure. And so it gives you the ability to scale Azure up and down with Kubernetes baked into that. Now, if you wanted to use Azure to build a multi-cloud cluster, you would probably have to build some kind of DIY type environment to where um, you have your virtual machines running on those multiple clouds. You could actually have your master nodes on multiple clouds, and then put your agents on multiple clouds, and then but you'd have to set that up. I would recommend doing it manually, not use Azure Container Services as a way of doing that. However, yeah, you could use Azure and Kubernetes to do a multi-cloud cluster. You just have to figure out the networking and then distribute your agents and your master nodes across both clouds or multiple clouds or a hybrid cloud if you're doing it on-prem and in the cloud too. How are container OSs patched? Depending on the scenario, if it's Azure Container Instances, or then you have to patch that because it's not a fully managed platform. If it's running on Azure Container Instances, or app services or what have you, Microsoft maintains those operating systems, so they're going to patch those for you. So uh, whenever you're in just the general sense of that, generally your OSs are patched separate from your containers, so you don't patch your containers OS, with a container. Typically, the way you patch a container is you discard the old container, you redeploy the image. Yeah, so if you have a patch, you patch the image, you throw away the containers using the old image, and then redeploy it with the latest image. Now, the container OSs underneath that, you would have to patch using traditional means like you would otherwise do for traditional VMs or bare metal. What kind of security controls are there built in and available to containers? Data encryption, secure transport, etc. Good question. The security controls that are baked into to containers is as broad. The idea is with container orchestration is generally pessimistic. It doesn't give you much out of the box. You have to kind of turn stuff on. So the security controls is basically what you make it. So like for instance, I can actually expose my Docker environment wide open to the internet and then have it running there on the internet, or I can lock it down to where the only way I can access it is on the machine is actually running on, or something like that. Now, typically these will like for the orchestration, for instance, they all use TLS to communicate between different nodes on the containers. You can set up controlled access ACLs on the container master nodes that will only allow certain IPs to attach to it or certain users and so on. So it depends a lot on the actual the engine that you're using. I would so my data encryption again, data at rest is data encryption. Again, you have data in flight. If you're using SSL connections back to your containers for websites and stuff like that. Yeah, I would encrypt it in transit, and and if you're, or you can use like what they call Docker volumes, using encrypted file systems and things like that on, uh, and then mount that volume into the container. And then there's also the ability to use Docker, what they call Docker secrets, which is the ability to encrypt things like passwords and connection strings to databases if you are using those. How much does the cost of the Docker registry? Is it calculated by image or the number of images? It's calculated based on the size of the instance. So they have a couple different tiers, and it's calculated based on basically the storage and then the ingress and outgress of that storage. So the one I demoed was basic. It is pretty cheap. It's like I think just a couple bucks a month for 10 gigs, so it's pretty cheap. And then you can scale that out. Obviously, you can have larger containers, but it's basically the size of the service you sign up for. Um, Perhaps you could elaborate more on with the containers for Windows. Would you recommend to use with Azure Batch for video rendering scenarios, or just running separate VMs? Um, Again, on Azure Batch, I'm not. Yeah, I mean, you could. If I was going to be running a lot of video rendering jobs, like I was doing this for a living, and I needed a workflow for video rendering, for instance, yeah, batch services is a great way to do that. If it's a one-off thing and I only have to render one video, that's a not that's probably VMs would probably work for that just as well. I would say for batch services, again, the intent here was um, the containers on batch services can be used for that. So yeah, if you just use it, if you're doing a lot of workloads there, I would recommend you could definitely use batch services for that purpose. Let's see what we have here. Did did pull nano server inside? What is the status on the insider builds multi-stage now with that core 2.0 is released? I'm guessing I have okay. I'm not I don't understand the full intent of this question from Martin, but it's I haven't really checked out the nano server and build, but I yes, multi-stage build is not a function of nano server, it's a function of Docker. So Docker, the latest versions of Docker are going to have multi-stage builds in those, and it does work with Core 2.0. You could because multi-stage build is a you can actually use the container to build the the app. So what you would do is you'd have one container build it, then the output of that container would drop into the next container, which would actually be the one that you would use to run that with. Um, so the multi-stage build is a function of the actual of Docker itself. It's not something that is supported by. It's not a function of Nano Server or anything like that. So yes, you can use Nano Server with multi-stage builds. Just make sure your Docker instance, your Docker CLI is up to date. Will it cost more money to use in containers concurrently than using Azure Batch that will run in containers concurrently to reach um, one equals? Um, Azure Batch, because it's basically using compute nodes. It's using compute nodes under the hood to do a lot of that uh, work. So it's basically billing you based on the how much you use the compute nodes underneath those. So it's really not a function of the number of containers as much as it is the amount of compute that you're running on Azure. So whether you're using Azure Container Instances, Azure Container Services, or you're using Azure Batch, that's more a function of how many VMs are you running and the what level of VM are you running? Are you running a multi-core VM with a lot of RAM? That's going to cost more than the more modest VMs. So it's not a function of so much as the container number of containers as it is as it is the number of VMs in your pool on batch services or the number of agents that you have on Azure Container Services and so on. So the issue is that's really not a function. So figure out the cost in that respect, not so much in terms of VMs, not in terms of number of containers. What is the technology implemented in Azure Batch? What do you have inside on the queue, fine control over scheduling, etc. Because this really isn't a webinar about Batch. The technology under the hood with Batch is it's really just using is essentially just using VMs under the hood, like I was saying a minute ago, and it does give you pretty fine grained control over scheduling. I think up to minutes, and you can schedule those essentially like you would a cron tab or a cron job. Um, you have fine grained control over when they run and how often they run. Um, and the queues are basically just whenever you put it into the queue and how it processes, you can monitor the queues and see what's running, how long it took to run it, all that kind of thing. But under the hood, it's really just using it's using VMs and it's putting an agent on that VM and it's using telemetry back and forth between that agent and on the VM and your batch service instance to do that. And it's the same with the containers. So the containers running on that are just the workload is in a container, but it's still monitoring it in the same way that it would if it was not running in a container. When a new container initiates, how does it authenticate with the OS? A new container doesn't really authenticate with the OS per se, because the instantiation of that container is typically done by somebody or something that's already authenticated on the OS. So and the containers themselves will run as whatever user you tell them to run as on the OS. So whenever you set your container environments up, you typically want to set up trusted registries or only pull from images that you actually trust. And you want to do that with an authenticated user on the container environment. So you would set that up a priori. You know who's pulling that. So that's how it's not something that the container authenticates with. It's actually the user that's installing that on there. Are there any services on the Docker ecosystem that available like Flocker? Flocker being a file system, I believe, for Docker. If you have with Azure Container Services, you can install uh, volume drivers on that. Other services from Docker ecosystem available like Flocker. Yes, you can install any of those on any Azure Container Services. You can do that, um, um, and so on. You can definitely see that. I cannot see the screen of the presentation. And let's look at this last question. The Azure Batch itself is a service free. We only pay for the. Yeah, another question about Batch. Is it free? It's not free. This you pretty much just pay for the VMs. The scheduling and all that is yeah, that's just the service on top of it. But you're really paying for the compute under the hood there. Uh, all right, let's see. So if we have any more questions at the bottom, I think that's all of them. So. Um, So that's any more questions, please pose them. We have a few minutes left. Those are a lot of questions. I hope that I was able to answer them for you. Um, can we see a demo of Azure Batch? I'm assuming. Um, can we see the MSTCS, MSTSC, or to that? I'm not sure I understand the intent of the question there. Um, Anyway, um, can you pervert more about containers? Okay, let's great presentation. Is there any good references I can learn more about containers? Yeah, I would point you to definitely go out to winelect.com. We have a lot of resources there on containers. I would recommend go out there and check out winelect.com. We have a lot of blog posts on containers, and we have some past webinars we've done and some past speaking engagements we've done. Go out to docker.com and just learn about how to build container images and look through the tutorials there. Docker has a lot of good hands-on labs that you can use as well. And then follow me on Twitter. I post constantly about anything and all things related to container technology. So if you follow me on Twitter, I pretty much post several things a day related to the latest and greatest news coming out of the container ecosystem. So it kind of keep you abreast of what's going on. I subscribe to dozens of different blogs, and I kind of find stuff that's new and then post that. And usually I don't like to post junk, so it's usually high quality stuff, and we'll focus on that. Another way to get to learn about containers is just hire us to do some training for you. We do offer hands-on training, on-site training. We have some training courses that you can do on Winelect now. We have an entire catalog of videos out there that can give you in-depth training on Docker and containers as well. And will there be a video link to distribute the this webinar? Yes, we will post this on Dev Center on winelect.com. We'll have a blog post out there with this webinar. We've recorded it, so it's definitely available for that. We'll probably edit some of the content just to make sure that it is, for size, and so we're not droning on constantly about things. Um, so definitely we'll be posting the seminar out there for you for future viewing and for folks that weren't able to log in today. So if there's no more questions, we had a lot of good questions, and I thank you guys for attending. I'm going to sign off now. If you have any questions, please feel free to ping me on Twitter. That's a great way to get a hold of me, and I'll gladly answer your questions there. And also comment on a blog post on winelike.com or reach out to us, and we'll be glad to see what we can do to help you out in your journey with containers. Thank you for attending, and I hope you have a good rest of the afternoon.